From today's round. Code was round 787 div 3, Vlad and unfinished business. Okay, so the way we solve this is let's make a diagram. If this is, we've been given a tree and we've been given two vertices x and y. Let's say this is the tree. I don't know. Let's say this is the tree. We've been given two vertices x and y. Let's say this is x and this is y, and we've been given some vertices that are marked. By marked I mean that we need to visit those vertices for sure. So let's say the green vertices are marked. Let's say these vertices are marked. Okay. So let's say these vertices are marked. By marked, what we mean is we need to go from x, visit all the green vertices, and then eventually go to y. And we need to find the minimum path for doing so. Minimum path with a minimum length we need to find. So the way we solve this question is by first of all identifying that since we need to go from x, it might be helpful to root the tree at x. So if once we root the tree at x, the next observation would be that uh, the nodes can be basically organized into two sets. One is those nodes that lie in the path from x to y. That is, if this is the path from x to y, these nodes form one group, and the rest of the nodes form the other group. Now, the total time taken to get from x to y while visiting all the green vertices uh, in between, the minimum possible time can be achieved if we first visit all. So if this is the path, first we from x we first visit all the green vertices here, then all the green nodes here, and then finally we go to uh, the child which lies in the path from x to y, and we keep repeating this. Okay, this is the idea. So, and similarly for this, if we had these also, we would do the same. Now we need to store a few variables in this question. One that I've used is nw the array, which stores that which stores the number of green vertices, number of green nodes in the subtree. So nw of node stores the number of green vertices in the subtree rooted at node. So for example, here it would be 1, here it would be 0, here it would be 1, 0, 0, 1, oh sorry, 2 in this case. In this case it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 here, and so on. This is one variable that we store. Another variable, so once we have this, now we can populate this variable via a simple DFS, uh, simple tree DFS. That is no big issue. Now once we have populated this array, the next step would be to calculate time. How do we calculate time? For every, for let's say we are at this node, and these are the children. Okay, now for every child, if nw of child is 0, that means we don't even need to visit that particular child. But if the nw child value is greater than 0, then we have to visit that child, and the time of node, time required. Okay, so one variable was this. Another variable, another array that we need to maintain is tr, that is time required. Is time required to visit the subtree rooted at node. Okay, so tr of node would be incremented by 2. Why 2? Because first we have to go down, then we'll have to go up also. 2 plus time required in the child. So once we have gone down, we'll spend some time in the child, then we'll go up and come back to node. This is the idea. This is for the case when node is not in the path from x to y, because in the if node is lies in the path from x to y, tr node won't be increased by 2 plus trch, it would be increased by 1 plus trch. The logic being, uh, for nodes in the path from x to y, we only count the edge once. For in these vertices, we had to first go down and then come up, but in these edges, we just need to go down. Yeah. So yeah, this is pretty much it. This is pretty much the logic. The code is, I have written, I don't know, the reason I've used a lot of variables that is not necessary. It caused a lot of confusion for me during the contest. Also, I uh, miswrote this DFS answer to be DFS, and that led to me wasting like 30 minutes on a silly debugging mistake. But anyways, NW is what I spoke about. TR is what I spoke about. Is path node is, uh, does the node lie on the path from x to y? Is to is node, what is this to is node? Is to is node is the node a green node or not? By green node I mean this. Is the node this node or not? So first of all, we do a DFS1 to find the path from x to y. How does DFS1 look like? It is a simple, like we need to, by with DFS1 we're storing, when y is encountered, we are storing the paths from x to y. That's it. And this is the, and pop back push back method. This is the method uh, to maintain the path from root to the current node. Yeah. So DFS1 does this. From DFS1, once we have the paths, we populate the is path node vector. Then we populate NW with a simple DFS again. NW is the number of green vertices in the subtree rooted at node. Once that is done, we populate TR, that is the time required to visit the subarray rooted at node. Uh, and this is simple. This is what we discussed. Yeah, and once that is done, we report TRX. That's it.